In Factorization Tutorial 1B, Richard James will not attempt to solve problems, but Richard James will take a look at some of the difficulties that we have factorizing trinomials and also the result of introducing brackets into our factorization problems. Sometimes we introduce unnecessary brackets, and that may cause some deviation from the norm as it pertains to the logic that we are attempting to display in our solution. In this tutorial, the most challenging expression to be factorized is a trinomial. We will therefore take a general look at all of the possibilities as it pertains to the manipulation of signs when factorizing a trinomial, as the signs tend to be our greatest downfall when we do not get it right. There we have the general form of our trinomial, ax squared plus bx plus c. The general form of the trinomial is ax squared plus bx plus c. In factorizing it, we need to convert it to its quadratic form by resolving its middle term into its two components. We will be able to do this if we are able to determine which two numbers will give the same product as AC and will have a sum equal to B. And we will do that by taking a look at a particular example. There we have A and C, 4 and 7, and we need their product. A is the coefficient of x squared and C is the constant value at the end. A is equal to 4, C is equal to 7. As we have that right there, their product is 4 times 7 is equal to 28. The question is now, what two numbers have a product of 28 and a sum of 16? They have a product of 4 times 7, 28, and a sum of 16. We may want to look at all of the possibilities, or we may be very skillful and may identify the two numbers at once. In the event that some of us do not spot them immediately, let us take a look at all possibilities on the next slide. So of the numbers that multiply to give 28, we need the pair that has a sum of 16. Let us list all of the pairs of numbers that will have a product of 28. There they are. 1 multiplied by 28, 2, 14, 4 sevens, 28. So all of those will have a product of 28, but which pair will have a sum of 16? Let us take a look at their sums. There we have the sums. Which one has the sum of 16? 2 and 14. So we have identified them. As I said before, we have candidates that may be very skillful and identify them all at once, but I am just making this presentation right here so that we can be systematic about it if needs be. Of the pairs of numbers that have a product of 28, the one that has a sum of 16 is the pair that contains 2 and 4. 2 and 14 will therefore be the two coefficients of the middle term. The middle term, 16x, will therefore be resolved into its two components, 2x and 14x. So of the two numbers that have a product of 28, the pair that has a sum of 16 is a pair that contains 2 and 14. So 2 and 14 will be the coefficients of the two middle components, and we will resolve the middle coefficient or the middle term 16x into its two components, and they are 14x and 2x. In these exercises, we are discussing the process of resolving the middle term into its two components. We will not finish the factorization process. So this exercise that we are doing here, we are not factorizing the expressions that we have here. We are just taking a look at the trinomials and see how we can take a general look by making use of some examples of how to resolve the middle term into its two components. So we are not factorizing, or we are not about to complete the factorization process. The entire tutorial is based on factorization. Therefore, we do not need to complete the factorization here. We will have enough practice as we continue. Therefore, in this particular tutorial, which is 1B, we are not attempting to factorize, but to resolve the middle term of a trinomial into its two components. So here we have another situation. In this particular case, the product of A and C is negative. As we see, 3 for A and negative 8 for C. 3 times negative 8 is equal to negative 24. So the product is negative. The question is, which two numbers have a product of negative 24 and a sum of 10? The sum is actually positive 10. So they multiply to give a negative 24. When we add them, we get a positive 10. What are those two numbers? First of all, the product is negative. That tells us that the two numbers will have different signs. So as long as the product is negative, the two numbers will have different signs. Our experience in manipulating directed numbers tell us that if we add numbers with different signs, why we say add immediately? Because they need to give a sum of positive 10. So our experience in manipulating directed numbers tell us that if we add numbers with different signs, we have a subtraction problem in which we subtract the smaller from the larger, and the answer will take the same sign as the larger. So we need to add the two numbers, and we will have a positive 10. But when we multiply those two numbers, we get a negative 24. They therefore have different signs, and when we add numbers with different signs, we subtract, and the answer will take the same sign as the larger. So we are already saying that the result is positive. So of the two numbers, the positive one is larger. There we have the middle coefficient. It is positive. We have already established, because of the negative product, that the two numbers must have different signs. Because the middle coefficient is positive, we are sure that of the two numbers that have different signs, the larger one is positive. We will take a look at all of the possibilities. So let us say that again. The middle coefficient is positive. We have already established, because of the negative product, that the two numbers must have different signs. Because the middle coefficient is positive, which is the sum, is positive, we are sure that of the two numbers that have different signs, the larger one is positive. We will take a look at all of the possibilities on the next slide. Bearing in mind that because the sum of the two numbers that have different signs is positive, the larger one has to be positive. Let us first look at all of the pairs of numbers that have a product of 24. Do not forget that what we are attempting to do is identify the pair of numbers that have a product of negative 24 and a sum of positive 10. So we will write down all of the pairs that have a product of 24, but we have it in our minds already that we are talking about a negative 24 of which the two numbers must have different signs. So there they are. These will have a product of 24, these also, and also the other two. Let us take a look at their sums, which will actually turn out to be a difference because of the different signs. Remember that the larger number is required to be positive because the middle coefficient, which is actually their sum, is positive. Do not forget that when we multiply the numbers, we got a negative 24. They must have different signs. When we add them, we subtract the smaller from the larger and the answer will take the same sign as the larger. What we have here is a positive 10. Therefore, the larger has to be positive. So in what we are doing, again, from here on, the larger number has to be positive. So the middle coefficient, which is actually their sum, is positive. The larger one is positive. So there we have all of the possibilities with the larger one being positive, and we are capable of picking out among the four the one that will give us the correct answer. They have to have different signs because they multiply to give a negative 24. They add to give a positive 10. The larger one has to be positive. So there we have it. Of the pairs of numbers that have a product of negative 24, the one that has a sum, or more appropriately difference of 10, is the pair that contains positive 12 and negative 2. Positive 12 and negative 2 will be the two components of the middle coefficients. Alright, so we are converting this trinomial into the form where we have four terms, and that is the process that we are looking at in this particular video presentation at first. But to the end, we will take a look at the insertion of brackets and also any special case that we may have. Since addition is commutative, it does not matter which of the numbers is placed first. So we may place a positive 12, then a negative 2, or a negative 2 and a positive 12. Also, I have chosen to use a number that might cause a bit of problem or ambiguity. While neglecting the fact that the product is negative, some candidates might erroneously choose 6 and 4, because 6 times 4 is 24, and when we add 6 and 4 we get 10. So they may erroneously choose 6 and 4 as the two components because they have a product of 24 and a sum of 10. If we add 4 and 6 we get 10. If we multiply 4 by 6, we get 24. That might be some student's choice. However, that cannot be right because we have already established, because of the negative product, that the two numbers must have different signs. So cannot be 6 plus 4. Those do not have different signs. must be positive 12 and a negative 2. Here we have another product that is negative. 5 multiplied by negative 6 is equal to negative 30. The question is, which two numbers have a product of negative 30, which is the product of A and C, A and C, and a sum of negative 13, which is the value of B, negative 13. First of all, the product is negative. That tells us that the two numbers will have different signs. Our experience in manipulating directed numbers tells us that if we add numbers with different signs, we have a subtraction problem in which we subtract the smaller from the larger, and the answer will take the same sign as the larger. There we have the middle coefficient. It is negative. We have already established, because of the negative product, that the two numbers must have different signs. Because of the middle coefficient is negative, we are sure that of the two numbers that have different signs, the larger one is negative. We will take a look at all of the possibilities on the next slide. So we have 5 times negative 6 is negative 30. The two numbers that we are about to use, irrespective of what we do from henceforth, those two numbers must have different signs because their product is negative. Now their sum is negative. We know that when we add two numbers with different signs, we subtract the smaller from the larger, and the answer will take the same sign as the larger. The sum is negative, therefore the larger number has to be negative. Bearing in mind that because the sum of two numbers that have different signs is negative, the larger one has to be negative, as we just said on the previous slide. Let us first look at all of the pairs of numbers that have a product of 30. So those will have a product of 30. What do we know, or what do we imagine next? We need to look at the pair that has a sum of negative 13. They have different signs because when we multiply them we got a negative 30. So they have different signs. And when we add them, the result is negative. The larger one is negative. So let us take a look at their sums, which will actually turn out to be a difference because of the different signs. Remember that the larger number is required to be negative because the middle coefficient, which is actually their sum, is negative. So there we have the possibilities, and no doubt we can pick the correct one out of the mix. And I am just saying again that we are just being systematic about it. But we are sure that if students continue to do this, then we will not have to be so systematic about it, and students will be able to pick the correct one quite easily without having to go through all of this process. Because we will establish facts, and we will take a look at, by the time we are through with this, a rule of thumb that should help us greatly in narrowing down our possibilities very quickly, in order that we can zero in on the pair that actually works. Of the pair of numbers that have a product of negative 30, the one that has a sum, or more appropriately difference, of negative 13 is the pair that contains positive 2 and negative 15. positive 2 and negative 15 will be the two components middle coefficients. That is what we are doing in this portion of the video presentation, only resolving the middle component or the middle term into its two components, because we have enough factorization. When we continue, addition is commutative. Any one of the numbers may be placed first. Also, I have chosen numbers which might appear to be ambiguous, while neglecting the fact that the product is negative. One might erroneously choose 10 and 3 as the two components because they have a product of 30 and a sum of 13. So we may say, alright, which two numbers multiply to give 30 and add to give 13? 3 plus 10. 3 tens, 30. 3 plus 10, 13. There we have it. However, we are mindful of the fact that the product is negative and the two numbers must have different signs. That being the case, we will have a negative 7, or if the positive 10 is larger, we will have a positive 7 with 10 and 3 if the signs are different. Therefore, this pair will not give the correct answer, but I have included this example because students sometimes make an error like that. You know, you are trying to find, not necessarily that it is too far away, a particular value, and immediately a particular scenario turns out to give you the value that you are looking for. You do not pay attention to the specifics like the signs and so on, and you just go straight ahead and write them down. I'm not only demonstrating how to resolve these middle coefficients into their two components, but at the same time, and I am attempting to show you how students might make mistakes just because something else seems to work. And it is also very important for students to pay very serious attention to detail, that the signs do not elude you and you do not end up with something that appears to work and turns out to be incorrect. Our first product was positive, and this one is also positive. So we have another positive product right there. What do we know about positive product? Well, we can mention it as we go along, or we can just mention it here. As long as the product is positive, the two numbers have the same sign. The question is, which two numbers have a product of positive 40 and a sum of negative 13? First of all, the product is positive. That tells us that the two numbers will have the same sign. Not that the two of them are positive. The two of them will have the same sign. As I said before, not that the two of them are positive. The two numbers may be positive because a positive multiplied by a positive will give you a positive. Or the two numbers may be negative because a negative multiplied by a negative will give you a positive. So they will be both negative or they will be both positive. There we have our answer though. There we have the middle coefficient. It is negative. We have already established, because of the positive product, that the two numbers must have the same sign. Because the middle coefficient is negative, we are sure that both numbers are negative, because there is no way we can add two positive numbers and get a negative answer. So we know that the two numbers have the same sign because the product is positive. So they will be both positive or they will be both negative. If they are both positive, they cannot add to give a negative answer. So we have to conclude that they are both negative. One may quickly say, what about getting a negative answer by adding a positive and a negative answer? That will work. If we are adding a positive and a negative number and the negative is larger, then we are sure that the sum will be negative. So what about getting a negative answer by adding a positive and a negative answer? For sure, if we add a negative and a positive, it is possible for us to get a negative answer. But what is the problem? This may be done neglecting what we said before. We have already established that because of the positive product, the two numbers must have the same sign. The two numbers must therefore be negative. Remember that when we add numbers that have the same sign, the values are added and the answer will have the same sign as the numbers that we are adding. Let us therefore attempt to find the two numbers that have a product of 40. They have the same sign. Let us take a look at their sums, in which the values will be accumulated because the numbers have the same sign. Remember that the answer will have the same sign as the numbers that we are adding when we are adding numbers with the same sign. So there we have them. Same sign. -1 minus 40 is -41. -2 minus 20 is equal to -22. And we do the same for the others. And there we have identified the pair that works. Of the pairs of numbers that have a product of 40, the one that has a sum of -13 is the pair that contains -8 and -5. Resolve the middle term into its two components. We may establish a rule of thumb to help us resolve the middle coefficient into its two components. It has two parts. When the product of A and C is positive, we have an addition problem. So as long as the product of A and C is positive, we have an addition problem. The two numbers will have the same sign as the middle coefficient. So as long as when we do this we get positive, the two numbers will have the same sign. They will have the same sign. And if that being the case, we will have the two numbers that we add will have the same sign as the middle coefficient. So in this particular case, the middle coefficient is negative. The two numbers have the same sign. The two numbers are negative. In the first case, the product was positive. The middle coefficient was positive. The two numbers are positive. So that is what we have when the two numbers multiply to give a positive result. Then the other part of it is when the product is negative, we have a subtraction problem, and the sign of the middle coefficient will be the sign of the larger of the two numbers that we are adding. So when the product is positive, the two numbers have the same sign and they will have the same sign as the middle coefficient. When the product is negative, the two numbers will have different signs and the sign of the middle coefficient will be the sign of the larger one. Now we have a special occurrence when factorizing trinomial, and that special occurrence is the sum is greater than the product. So let us consider one special occurrence when factorizing trinomials, that is, when the sum is greater than the product. So we have right there 3 times 2 is equal to 6. So that is our product, and the sum is 7. The sum is greater than the product. Let us take a look at the pairs of numbers that have a product of 6. Only 6 1 and 2 3. The correct pair is 6 1 because 6 plus 1 is equal to 7. We also consider one in which the middle coefficient is negative. And do not forget that if the middle coefficient is negative and the product is positive, the two numbers have the same sign, and the sign that the two numbers will have is the same sign as the middle coefficient, which is negative. So those two numbers will be negative. The product of A and C is 2 times 5 is equal to a positive 10. And their sum is negative 11. Let us take a look at pairs of numbers that have a product of 10. 1 10 and 2 5. The correct pair is 10 1 because negative 10 minus 1 is equal to negative 11. Notice that in both cases one of the numbers is 1. We have shown that to be true in the two cases that we have examined. It may be proven to be generally true logically and also theoretically that when the sum is greater than the product, one of the numbers is 1. So continuing, we will not have such an occurrence when the product of A and C is negative. So when the product of A and C is negative, we cannot have the sum being greater than the product. The sum can only be greater than the product when the product is positive, and when it is positive alone. We will not have such an occurrence when the product of A and C is negative. That is, when the product is negative, there is no way that the sum can be greater than the product. This is because the largest factor that the product can have is the product itself. So the largest factor that the product can have is the product itself. If the product is negative, then we have a subtraction problem. If one of the number is the product itself, then we will be subtracting 1 from that number, and the result, which is the sum, will be less than the product. So take a look at this one. The product is 2 times 5, 10. The largest factor of the product is 10. And if one is 10, then the other one is 1. So if the sign of the two numbers are different, then we will have a subtraction problem. And instead of having 10 plus 1 is equal to 11, we have 10 minus 1, which is equal to 9. Therefore, the value will go down instead of up. And as long as the product is negative, which requires that the two numbers have different signs, then the sum can never be greater than the product. When the product is negative, there is no way that the sum can be greater than the product. This is because the largest factor that the product can have, as we said on the previous slide, is the product itself. If the product is negative, then we have a subtraction problem. if one of the number is the product itself, then we will be subtracting 1 from that number, and the result, which is the sum, will be less than the product. So let us take a look at an example of what that means. Say we have, this is our situation. We may establish immediately that the expression that we have right there cannot be factorized. The negative 5 at the end ensures it. But let us say that it were possible, and let us write down the factors of 10. So we are sure that the expression that we have there cannot be factorized. Why we are sure? Because the largest value of the product is 10. So the product is 10. And the signs are different. The product is negative. Therefore, there is no way that the sum can be greater than 10 if the expression can be factorized. So we may establish immediately that the expression cannot be factorized. The negative 5 that we have there at the end ensures it. But let us say that it were possible, and let us write down the factors of 10. The product would be 10, neglecting the negative sign. So the product will be 10 if we neglect the negative sign. The largest factor of 10 is surely 10. The only way that the sum may be greater than the product is if one of the number is the product itself. With one of the numbers being the product itself, the other must be 1. Now, the fact that we have neglected, we will accept. The sign of the 5 is actually negative. This will make the product negative, and we have seen before that the numbers will have different signs, resulting in a subtraction problem. So the signs are different. So we will have a subtraction problem because the product is negative. The signs must be different. We will have a subtraction problem. So there we have the subtraction problem. Either 10 minus 9, which is equal to 9, or negative 10 plus 1, which is equal to negative 9. So irrespective of the sign of the numbers themselves, the size of the sum will be less than the largest factor of 10, and will therefore also be less than the proposed sum, which is 11. So the proposed sum is 11. The largest value that we have here is 10. When we multiply these, we get 10 or a negative 10. This is not possible because the numbers have different signs. So we cannot say 10 plus 1 because they have different signs. We need to say 10 minus 1 or negative 10 plus 1, because we are actually subtracting 1 from the product all the time because of the negative sign, or we'll be subtracting something. Then there's no way that we can have a sum that is greater than 10. Another thing that needs to be addressed is the unnecessary insertion of brackets into the expression when factorizing by grouping. The unnecessary insertion of brackets. Let us resolve the middle term into its two components. Well, at this stage we are not looking at or examining how we resolve the terms. We are just looking at what happens, because students do it. They just insert brackets at will into their expressions, and in the end they get the correct answer, but the intermediate steps are not correct. And let us take a look at that. Maybe for the visual effects, or else I do not know why, students have a tendency to use brackets to group the pairs of terms that they are associating together in factorizing by grouping, which is totally unnecessary, because if they are grouping these two, they just take the first two, After taking those first two, they'll take the other two, and there's nothing else to it. But they always throw in brackets like that. If the brackets are placed as we have them there, as students sometimes do, then we have made an erroneous step. Inserting the brackets in such a way that there is no sign separating the pairs of brackets is an indication of multiplication. So because there is no sign between the brackets, we are multiplying. This means that we are multiplying the contents of the two brackets, which is not what was intended. So what will the students do? The students will make sure that a sign is separating the two brackets or the pairs of brackets instead. So what do they do then? We may make an adjustment that may very easily correct the problem. So make an adjustment. Right. Shift the bracket down some more and cause the sign to be out there. That will do it. For sure, the expression that we have there with the brackets and all is correct. The addition sign separating the pair of brackets ensures that our intentions are correctly depicted in the expression. Right, so by making this adjustment, we are sure that we have done the correct thing. That is correct, irrefutable. And we may leave our work just like that because we are sure that it is correct. What may be the consequence of inserting brackets in the expression when we have a variety of signs to contend with? So when we resolve the middle term into its two components, we have a variety of signs, some positives, some negatives. Group the pair of terms as usual. So group the pair of terms as usual. Group them. We have already discussed the disaster that may result in inserting pairs of brackets that are not separated by any sign. So we know that having the expressions like this is a disaster. We have discussed that already, because we are multiplying the contents of the brackets when we really do not intend that. What do we do then? Again, let us make an adjustment and see the consequence, which is move the bracket down some more, revealing the negative sign right there, which is what some students would do. Surely we are not multiplying the contents of the brackets here, therefore we have to be correct. I say that it is incorrect. The adjustment does not solve the problem, because that negative sign that we have preceding the second pair of brackets will be distributed to each term in the brackets. This causes the expression to be different from the initial one, which is never the intention of factorization. Let us see what that means. We are saying that this negative term will be distributed inside or to each term that is enclosed in the brackets, and that is not our intention. Let's see the result of doing that. We have that negative sign being multiplied by this positive term. The result is negative. And what do we have next? Negative multiplied by positive is negative. Negative 12 here whereas we started with a positive 12. Notice that by expanding the second pair of brackets, as we have them right there, we have a negative 12 resulting, rather than the positive 12 that we had before. So no doubt we would have made an error, or the logic of our solution has been greatly disturbed. This is an indication that inserting the brackets in the expression in the way that we did actually constitutes an error. The problem that we have just encountered will always be encountered when we have a negative sign preceding the second pair of brackets. So when we have a negative sign preceding the second pair of brackets, if we just throw in brackets, then we are going to have some difficulty, as long as a negative sign is preceding the second pair. Whenever this occurs, if we intend to insert brackets, then we will have to adjust the expression in order to preserve it by changing the sign of the second term that is inside of the second pair of brackets. So we will insert our brackets for sure, but what we will do when there's a negative sign that begins the second pair, throw in the brackets and change the sign of the second term that is inside of the second pair of brackets. And if we do our expansion again, we will realize that we have a negative 3x as usual, and that negative times negative is positive, which is really making a big thing out of nothing at all, because we shouldn't really be including brackets. Notice that on this occasion, the entire expression is preserved. It would be very nice if we could insert our brackets all of the time, and if necessary, make the minor adjustment inside of the brackets. So it would be good if all the time throw in our brackets, since we are bent on always doing that. But in the event that we have a negative sign preceding the second pair, we will change the sign of the second term that is enclosed in those brackets, and that should always do it. However, I think that it would be more appropriate and straightforward if we leave the brackets alone. As a matter of fact, some of the few things that I always tell my students not to include are unnecessary brackets. There are a few things that I always tell my students not to include in the solution of a problem. Do not include unnecessary brackets. Do not introduce an unnecessary negative sign, and do not introduce an unnecessary fraction. But of those, well, we have some more that we shouldn't really include, but unnecessary brackets are really at the top of the list of things not to include when we are solving a problem. I am sure that none of you is so visually impaired and mentally disorganized that you cannot just look at two terms and factorize them, then look at another two and factorize them, even though they are in the same expression. So I am saying that, of course, we can just take a look at the entire expression with four terms. Just take a look at two terms. We are not looking at the first and the third, the second and the first. All that we are doing is taking a look at the two terms that follow one behind the other, and then we look at the other two. And I am sure that we do not need any assistance to organize them in a visual way in order to distinguish between are among the pair of numbers. In the event, because we will see that in the tutorial as we go along, in the event that when we are attempting to factorize an expression like this, then there is no match or there is no common factor that we can see immediately, then you know that we have to take maybe the first and the third. But if we have a situation like that, what we should do is actually make a step in which we put the terms that we intend to put together or to group together in a contiguous fashion. We do not jump and include brackets or all different devices in our expression just for the visual effect, when we know that all we are doing is taking two terms and then taking another two. So what I'm saying is that if the terms are not arranged initially to our liking, then we should arrange them in such a way that we take the first two and then we take another two, rather than inserting brackets. As we have shown, it is not impossible to insert brackets in all circumstances and still be correct. However, sometimes the erroneous insertion of brackets may not affect accuracy of the final answer, but it is devastating to the logic of the steps. Sometimes the erroneous insertion of brackets may not affect the accuracy of the final answer, but it is devastating to the logic of the step. So we go through and we get the correct answer anyway, but inside there, in making the steps, we would have done some great injustice to the logic from which the answer should follow. So that's a possibility also. Although the introduction of brackets can cause problems, it is necessary to understand how they may be correctly introduced. Not necessarily in an examination in which we have time constraint, and especially that it may require adjustment in the expression, but may be necessary in correcting fellow students' errors in a practice session or otherwise, or at least by this video presentation, students will get a good understanding of how horrible the logic of our solution may be affected by the introduction of brackets. And as a matter of fact, I have demonstrated how they may be correctly introduced. But for sure, by the time we are through with these tutorials, students should have the hang of factorization and be weaned of the brackets by the time we are through.